This lesson is on complex numbers, and complex numbers just means i's, and you've probably dealt with these before in previous math classes. So just as a reminder, I is the square root of -1, so it's not a real number, it's outside of the real numbers, and we need to be able to manipulate it. So we need to know what these others in the pattern are, and the pattern is 4 sections long. So if I is the square root of -1, then I squared would be the square root of -1 squared. And we all know what happens when you have a square root and a square. They cancel because they're inverses of each other, and -1. So anytime you see an I squared, you're going to replace it with -1. And this is the one that gets used most often when we do replace things. I to the third would be I squared times I. That's how you would get the third power. And since I squared is -1, -1 times I would be -I. And so anytime you see an I to the third, you can replace it with a -I and make the problem look simpler. And then I to the fourth. I to the fourth is I squared times I squared. And if I squared is -1, -1 times -1 is a +1. So our pattern, which we may refer to in a little bit, is I, -1, -I, 1. Okay, and so I tell people to remember it like you won the lottery. I won, and then it's just positive, negative, negative, positive. Okay, moving on to what we need to be able to do with these. The standard form of a complex number is a plus bi, a being the number that doesn't have an I with it, the regular real looking number, and then the bi is however many i's that we have. And so we're just saying that we put the number first and then the part with the I second, and that is the standard form. In our examples, we just need to be able to do the general activities with these. So I have 3 minus I plus 2 plus 3i. When it's plus, it's really easy. Just combine the ones that have things that are alike. So I can combine this 3 and this 2 and say 3 plus 2 and get 5. I can combine this -I with this 3i. So -I plus 3i would be like -1 plus 3. So it would be a +2, but they have i's. So 5 plus 2i would be my answer here. When you're doing subtraction with these, be careful because you want to make sure if this had been a subtract that you subtract the number after it and you check your signs to make sure you've done those correctly. Example 2, we are not written as i's yet. So for any problem that is not written as i's, if they have square roots of negatives, turn them into i's first. That should be your first step. So the first thing I'm going to do is think the square root of 4 is 2 and I have a negative there. So this becomes 2i. And then I'm adding to that 4 minus, again, a 2i because the square root of 4 is 2 and then the negative underneath the square root is like a -1 under a square root, so it's an I. So I write the i's and then I combine what I can. I don't have a plain number with this, so it's like a 0. So 0 plus 4 would be 4. And then 2i plus -2i would be gone because those cancel each other out. So this actually just became 4 as an answer. Example 3 has a little bit more to it. I have 3 minus -2 plus 3i plus -5 plus I. I can take all the parts that are the number parts, so let me highlight those, and put those together. Just use the correct sign. So here I have a subtraction. 3 minus -2 would be a +5. Plus a -5 would be 0. So I got a +5 here, add -5, got 0. Now I can combine the i's, and there was no I out here, so I just move on to this next part. 3i plus I would be 4i. So 0 plus 4i is what I get from this, and I could just write that as 4i. Number 4 is another example where the i's are not written first, and you need to turn those into i's before you do anything else. This is especially important when you're multiplying. So negative 4 under the square root would be 2i. We've done that one. Then the square root of negative 16. The square root of 16 is 4, so this one would be 4i. So I've turned this into 2i times 4i. Now I can multiply, and you just multiply the numbers. So 2i times 4i would be 8, and then you add the exponents on the i's. So I times I would be I squared. This is where that stuff came in at the beginning. Anytime you get an I squared, you change it to a negative 1. So this is the same as 8 times negative 1. So my answer is negative 8. If you had not taken your i's out first, you would get the sign of your answer wrong. So be careful with that. Conjugates. Conjugates we used with square roots before, and I just want to remind you what those are. With i's, it works the same way because they represent a square root. Conjugates, I have 7 minus 2i and 7 plus 2i. They just have a different sign in the middle. The first number that keeps the same sign, but the sign in the middle changes for those. So for example 5, if I wanted to find the conjugate of negative 12 plus 5i, the negative 12 would stay the same, but the middle sign would become a minus. So negative 12 minus 5i. And why we need that is pretty much the same reason we needed it before when we had square roots, is for these fractions. And these are our last couple of examples. We have to rationalize, and so I'm going to multiply by the conjugate of the bottom. And so in this case, that would be 4 plus 2i. And when you do that, because these have binomial pieces, you're going to have to FOIL. So I'm going to FOIL on top and on the bottom, and there's going to be a lot to simplify. So 2 times 4 is 8. 2 times 2i is 4i. 3i times 4 is 12i. 3i times 2i is 5i squared. And don't forget that. I almost made a mistake and forgot to square that. Then on the bottom, 4 times 4 is 16. 4 times 2i would be 8i. Negative 2i times 4 would be negative 8i. And negative 2i times positive 2i would be a negative 4i squared. And the reason that we did the whole conjugate of the bottom was because now these are going to cancel, and when I simplify, I'm not going to have i's on the bottom anymore. The top, I have 8, 4i, and 12i would be 16i. And then 5i squared is like saying 5 times negative 1. So that would be a negative 5. On the bottom, I have the 16. And then I have negative 4 times I squared. I squared is negative 1. So negative 4 times negative 1 is positive 4. So I can simplify again. I can add my 8 and my negative 5 and get a 3. So I have 3 plus 16i on top. And then 16 plus 4 is 20 on the bottom. And so this would be my final answer. Occasionally over here you get something that will reduce. If the 3 had been a 4, I would have a 4, a 16, and a 20, and those would all reduce by 4, and you would reduce that fraction. So watch for those. Lastly, example 7 is also a a fraction, and it's not as easy to figure out what to multiply by. If you don't have the number plus an I or number minus an I, it's just a 0, then you can actually just multiply by the I over the I, and it will go away. So 3 times I on top would be 3i. I times I on the bottom would be I squared. And like we said, I squared turns into negative 1. Well, we normally don't write fractions over 1. I can just move that negative up and say that this is negative 3i. So this is kind of a simpler version, but sometimes people get stumped on the simple things, so I wanted to show you one. That's basically what you need to be able to work with i's for today. So that concludes this lesson, and I will see you tomorrow.